Have me by your side when the sun sets.
Welcome guys to today's class. In today's video, we want to use the opportunity to answer some questions some of you guys have asked on my DM. If today is your first time of seeing our video, please click the subscribe button, like button, comment and share to your friends. Definitely you will enjoy many of our videos on our channel. Yes. So as I said, I want to look into some questions some of you guys have asked on my DM. Question number 1 is, how do I know that the slope of the graph I plot is going to be positive or is going to be negative? Especially if the graph goes like this or goes like this. You know, the popular one we know is this one and this one. That is for you that know it very well. Are you getting it? But this one and this one, most persons don't know how to get it. So that will be number 1 thing we want to sort out in this video. As you know how to get the slope, whether it will be positive or negative, we also want to know about intercept. We'll discuss that. Again, we want to see how to find standard error in G after plotting simple pendulum experiment graph. You have performed the experiment, you have plotted the graph, you have gotten your G, and you are asked to get standard error in G. We'll have a lot to discuss. Please and please, you know, it is you guys that are promoting my channel. Thank you all. I appreciate. So if you find my videos interesting, keep supporting me by sharing it to your classmates, sharing it to your friends. Yes, don't forget to click subscribe, comment, click like button, turn your notification button on so that anytime I post new videos, you will be the first to watch it. Okay, let's see. Coming to this, if I want to, after plotting a graph, let's say, let's not label the graph because here can be anything, here can be anything. Okay, let's say graph of V against what? I, because it's a straight line graph. Now, we finish plotting it. There is something we used to say about slope. We say that slope of every straight line is collinear. Slope of every straight line is what? Collinear. Look at what we mean by collinear. What does it mean? It means that if I take the slope from here to here, or I take it from here to here, or I take it from here to here, they will all give me same slope. Slope of this one will be the same with this or nearly the same with this, will be the same with the bigger one or nearly with that. Yes, like if I get the slope of this one to be 1, the next one can be 1.1, 0.9 or even 1. Are you getting what we are saying? So slope of this, if you get it to be 1, then put your unit to it if it has unit. If you get the slope of the next one, it can give you 1 or can give you, let's say, something about 0.9 or can also give you 1.1, just slight difference, so to speak. Okay, so that is about first point you should note. Every straight line you plot after plotting your graph, every straight line you put as a slope is collinear. Their slope is always what? Collinear. That is, they are always the same, either exactly the same or closely what? Same. Now, that is by the way. We take one of each. We want to see how to what? Get our what? Slope and know whether it will be positive or what? Negative. First thing you say is change in V, because your vertical is V, all over change in I. we say let it be that we are plotting graph of V against what? I. Now, change in V mean V2 minus V1 equals to V2 minus V1 all over I2 minus I1. So how do we get them? We put our what? With your ruler. Okay? You put your vertical line and your horizontal line. Then you now say this upper part will be taken to be V2. And the lower part will be taken to be what? V1. Then, where this vertical and the horizontal meet, look at where they meet. Where the vertical and horizontal meet, you trace it down. That will be your I2. Then, this other one will now be your I1. So don't forget it. Where your vertical and horizontal meet becomes your I2. Always. Always. Okay? Now, let's take here to be 1 and take here to be 5. How did you, why are we calling here 1 and calling here 5? This is origin. This is origin. So, O, this is 0. And this is 1, 2, 3, 4, 5. We are taking here to be 1 and be taking here to be 5. Because here have to be higher than this part. Then we'll take here to be, let's say, 4. And take here to be, let's say, 2. We are just giving some assumption. But it is when you have plotted this graph. It is only when you have plotted the graph, you will have values that are here and have values that are on the horizontal side. You must have the values that are on the vertical side and values that are on the horizontal side. It's not that when you plot your own, you take here to be 2 and take here to be 4, take here to be 5 and take here to be 1. No. These numbers I am putting here are not constant. It varies depending on what to take as your scale on the vertical axis and on the horizontal axis. If after taking your scale and where this your V1 is, that is pointing at 3, you write 3. If it is pointing at 1, you write 1. If it is pointing at 0, you write 0. If you're pointing at 4, you write 4. Are you getting it? Then where this one is also pointing at, you write it. But here should be higher than this. If here is 2 and here is, let's say, 4, it is wrong. You can't be starting from 0. After counting 1, 2, 3, it says 0, 1, 2. Do you say 0, 1, 4, 3? Do you count down or do you count up? You count up now, not so. Yes. Say 0, 1, 2, 3, 4. I get it. That means the one here is always higher than this one. And so our V2 will be what? 4. Minus our V1 is what? 2. All over our I2, where the vertical and the horizontal meet. Where the vertical and horizontal meet, we take it to, we say, let's here be our 5. Minus, we now say, this point is 1. We say, let it be 1. So, 4 minus 2 will be giving you 2. All over, 5 minus 1 will be giving you 4. 2 over 4 is plus 0.5. That means the slope of this graph is positive because your V2 is higher than V1 and your I2 is higher than I1. Noted. Then if they ask you to find the intercept, most times they specify intercept on the vertical axis. It means where this line of best fit, we call this line of best fit or least square line or regression line. That is words we can use to call this line. Line of best fit or least square line. Line of best fit or least square line or regression line. Okay, so they are synonymous. They are pointing at what? This straight line you draw. So if they talk about intercept simply mean this straight line, this line of best fit, where does it cut across the vertical axis? If they say intercept on the vertical axis, ask yourself, this line of best fit, where does it cut across the vertical axis? Where does it touch this vertical axis? Where does it meet this vertical axis? I've used different grammar to talk about it, right? Okay, so where it meets this vertical axis, you note it. You take the value there and write it as your word, intercept. You just say intercept equals to, okay, if here is 0 and here is 1, that means intercept here might be about 1.5. If here is 2, okay, might be about, look at it, it might be about approximately 2 self, because this 2, look at it, we say it's located here. The 2 is located here, so it might be approximately about what? 2. Where it meets your vertical axis, check your own graph. We are just using a sketch of graph here, okay? Where it meets your vertical axis is what you take as your intercept on the vertical axis. If this line cuts this or touch this horizontal axis, if it is this horizontal axis that it touch, it didn't touch the vertical, and they say line of intercept on the horizontal axis, please take it. Intercept on the what? Horizontal axis. Now, assuming it's cutting across this vertical line like this, it's cutting across this vertical line, and they say find the intercept on the horizontal axis. Find the intercept on the horizontal axis. Do you know what it means? As it has touched the vertical axis, not horizontal, you continue drawing this line till it meets this what? So you continue drawing it, let it meet the horizontal what? Axis. Where it meets this horizontal axis is what you now take as your answer. So it's not a must that the intercept will be on the vertical. But when they just say find the intercept, focus your mind on the vertical only. But when they say intercept on the horizontal axis, please, as you plot your line of best fit, as you locate your line of best fit, extend it to touch your horizontal axis and pick where it meets your horizontal axis. Note that point and write it out. You are writing out the point based on the scale you use. We have discussed scale on our channel. How to choose appropriate scale. We have discussed it. Check our channel, Chidons Daniel. How to choose appropriate scale for graphing. You will be able to what? Learn more about that. Just write Chidons Daniel. Chidons Daniel, CHY. Chidons Daniel, how to choose appropriate scale during graph plotting. You'll be able to what? Get it. Chidons Daniel. So what we are saying in essence is that 1, if they ask you to find slope, note that this is a vertical, the highest point of the vertical on, look at the lowest point. Take the point here, you write. Take the point here, you write. But you must take the formula, change in this, all over change in this. Change in vertical on, all over change in horizontal on. That means V2 minus V1, all over I2 minus I1. Noted. So take the V2 out. Take your V1 out, subtract. Then where the vertical and horizontal meet, Where the vertical and horizontal line meet, look at where they meet, trace it down and note your I2. If you are talking about V against I, note your I2. Then the other one automatically becomes your I1. Trace it down to horizontal, you take it out. Then you subtract and divide. That gives you your slope. In this case, the slope is positive. That means 2 over 4 will be giving you 0.5 plus 0.5. The unit of V, you write it all over the unit of I is ampere. This one is volt. Okay, all over ampere. If you do not put your unit of your slope, you have failed that question. I am shouting it so that you understand it very well. It's very important. If you just finish solving your slope, you must put your unit by the side of it. If it does not have unit, let's say here is V and the unit is V, and here is I and the unit is V, for instance, if both of their units are equal, it means V divide V, they will cancel. It will not give you what? Any unit. Like you are plotting something, here is centimeter and here is centimeter, they will cancel out now, so it will not have unit. When your slope is not meant to have unit and you put unit, you have failed it. When your slope is meant to have unit and you do not put your unit by the side, you have failed it. Just take note of that. It depends on you to be careful on what you are doing now. Okay. Then we talk about intercept. We say, when they say find the intercept, take your mind to intercept on the vertical axis. Remember, I don't call this y-axis because here it can be V, it can be K, it can be, depending on what you are plotting. If you are plotting Y again, it becomes y-axis. If it's V, you call it V-axis. You don't call it y-axis. Are you getting the point? You don't call it y-axis. You call it the parameter you are plotting, V-axis. If it is I-axis. If it is C-axis. Okay? So, if they ask you to find intercept, take your mind to intercept on the vertical axis. That means, where does it meet your y-axis? Where does it touch the y-axis? Take the point where it touches your y-axis. That becomes your answer. So, if here is 2, for instance, if this point is 2, tell them that my intercept will be equals to, what is the unit of V? Volt. If you are writing down the intercept value and you didn't attach the unit to it, you have failed it. Because this vertical axis has unit. So the intercept is equals to, if it is 2, you write 2, you attach the unit volt. If it is 1, you write 1. If it is 10, you write 10. You attach the unit volt. Just note where it touched the y-axis or the vertical axis, so to speak. Then if they say, find the intercept on the horizontal axis. Find the intercept on the I-axis. The implication is that this line only touch the what? Vertical one. You have to extend it. Extend it and also extend your horizontal axis so that this intercept can touch the horizontal axis. So wherever you touch the horizontal axis, you also what? Write it and attach the unit of ampere to it. Because that is the unit of what? Horizontal axis. If you are writing the intercept of the horizontal one and you didn't put ampere, you are wrong. Yes, we don't know whether it is, let's say that here is 3, for instance, now. And you are saying intercept on the I-axis, you are saying it is 3. We don't know whether it's 3 naira or $3 or 3 amperes. So that is why you are wrong. So you need to specify the unit and put ampere. That is about this case. Okay? So anytime they ask you to get slope on this, be able to know that the slope will be positive and be able to extrapolate the intercept, or if they specify intercept on horizontal axis, be able to get your intercept correctly. Do you also know that graph, if the graph goes this way, if the graph goes this way, you can still find your slope by same method. You just do it like this. This is your what? Let's say V against what? I. Then here is V2 and here is what? V1. And here is I2, where the vertical and horizontal meet, I2, and here I1, right? Then check the value here. Let's say the value here is 5 and the value here is 3. Check the value here. Let's say the value here is 4 and value here is 3, for instance. Depending on the scale you use, so that means change in V all over change in I will be equal to, what is your V2? 5. What is your V1? 3. All over, what is your I2? I2 means 4. And what is your I1? 3. Answer will be 2 volts per amps. Noted. Okay. Now, I want to tell you something. In this case, they can ask you to find the intercept on horizontal axis. If they say find the intercept on horizontal axis, it is already on horizontal axis. And so, what you just do is take the point where it meets horizontal axis. Let's say here is 2. We say our intercept on the horizontal axis is equal to 2 amperes. Are you getting it? Then if they say find the intercept, take your mind to intercept on the vertical what? Axis. Take your mind to intercept on the vertical axis. And so extend this line down and what? Extend this your line of best fit to this point. And when you extend it, you will be able to see the intercept on vertical axis. Are you getting it? So once you get it, that means intercept on vertical axis, here is 0. Here is 0. It's not a must that here will be 0. Be able to check your scale, the scale you use. If you check our channel, we have plotted different types of graphs now. So check your scale well. Check your scale well and count accordingly. So take what you get here to be your intercept and write it. When you write it, the answer should be about negative or positive depending on the scale you use. Take for instance, if here is 0, it means that what you should be having here should be negative. It should be negative value for vertical aspect. Intercept on the vertical, it should be negative if here is 0. Are you getting what I'm saying? So if here is 0, we can take here to be -1, -2. So here can be -2 what? Volts. Okay? Here is -2 volts. Take note of that. Then, if here is not 0, assuming that your vertical axis, you didn't start from 0. Maybe your vertical axis, you are starting from 2. You are starting from 2 to plot your graph. Yes, because if you check out our videos on our channel, you will see a video where I discuss different type of graph. I mean, different ways you can package your graph depending on when they say start from origin and when they do not specify start from origin. Here now, they didn't specify start from origin, and so you started with 2 because you want to make sure that your graph balance very well. Are you getting what I'm saying? And so, if here is 2, if your starting point for vertical axis is 2, that means here should be 1. It's possible that here will be 0. Your intercept might be at 0, so to speak. Or, if it is at 0, you come and write what? Our intercept will be at 0 what? Volts. So, it depends on the way you choose your scale, on the way you started your graph, whether you are starting from origin or you did not start from what? Origin. Calculate it well. If you want to see more videos about this, check our channels and be able to what? See how we discuss different types of graph, different ways you can choose your scale so that you'll be able to what? Balance your graph excellently well. So we've been able to see that we can get the slope of this. And the slope of any graph going like this is always what? Positive. Now, we want to see about this graph. You just finished plotting a graph of price and quantity what? Demanded. This is a graph of price and quantity demand, and you are getting this slope. We now say that take your vertical and take your what? Horizontal. This will be your what? P2, the highest point of P. And this will be your what? P1. Now, where the vertical and horizontal meet, look at where they meet. The vertical and horizontal, take it down and call it your Q2. The two parts is where the vertical and horizontal meet. You take it down. The automatically here becomes your Q1. You now say that your slope will be equal to change in P over change in what? Q. Right? What is change in P? P2 minus P1 all over Q2 minus Q1. Automatically, P2 is higher than P1. If here is 5, if P2 is 5 and P1 is 1, and Q2 is about 1, and Q1 is about, let's say, 4, because it must be higher than this. You are starting from, let's say, 0 now. 0, 1 to 4. You don't say 0, 4 to 1. No, you don't do it like that. Okay? So, you now compute, you say 5 minus what? 1 all over 1 minus what? 4. That will be giving you 4 over minus 3. You see the slope is what? 4 over minus 3. That will be the slope. What is the unit of price? Naira. What is the unit of what? Quantity. In unit, for instance. So we say the unit will be naira per what? Unit. Naira per unit. You must attach your what? Unit to your answer. Depend on the unit of your vertical axis and unit of your horizontal what? Axis. Please don't forget that. It's very important. Then we go back. When they say find the intercept, find the intercept. It means find the intercept on the vertical axis. But sometimes they can specify find the intercept on the vertical and on the horizontal axis. It means that get the intercept of P. Let's say here is 6. Intercept of P is 6. Intercept of Q is equal to what? 4. So intercept of P is 6 naira. 6 naira. If the unit is not there, you are wrong. Intercept of Q is what? 4 units. Are you getting what we are saying? Then, but when they just say get the intercept, just take the one of your vertical own, unless they specify the intercept on the vertical and intercept on the what? Horizontal. Or they just specify get the intercept on the horizontal axis or intercept on the quantity demanded axis, where Q is quantity demanded and P is price. Okay? It means if they say get the intercept on the quantity demanded axis, it means only talk about Q on IQ. But if they say find the intercept on the vertical axis or just find the intercept, take the one of P, that is just it. Then if they specify find the intercept on the vertical and on the horizontal axis, be able to take the two. Very important. And attach your unit. If I forget to attach my own unit here, don't say because I forget, you too will forget. No. I have sound this warning. Make sure that you go by your unit with whatever you are solving. If it does not have unit, don't put your own unit. But if it has unit, package the unit well. Slope, this will be at the top and this will be at the down. Simple. That is how we package it. Yes. On our channel, we've been able to get how to find error in slope. And I plead with you, please check our channel on this Chidon's Daniel, how to find error in slope. You will see a lot to learn. Or Chidon's Daniel, Introduction to Physics Practicals. You will see a lot to learn that we discussed there. Yes, we are here to make sure you get the best of science. Okay. Coming to this one now, if you want to what, know whether the slope will be positive, like this one is negative slope, the negative can be down or up. You don't want to write it at the down, you can write it at the top. It's the same. It can be at the down, it can be at the top. Note that. Don't say this one will put minus at the down. So it's not the same with when the minus is at the top. No, we don't do like that. Okay, come to this now. We have taken our what? Drawing, where our vertical and our horizontal. Here will be our what? Let's say we are plotting a graph of V against I. V against I. V against I. Then what you need to do is you trace this to this point. When you trace it, let's say here is minus 1 and that the starting point is 0, and here is minus 5, and here is 4, and here is 1, positive 1, because this is positive x-axis, positive horizontal axis, and negative y-axis. So this is minus v, negative y-axis, minus v. This is negative y-axis. Okay? Remember, before you plot your graph, that graph must have title. We have talked about it in our video before now. I just concentrate on the slope. It must have title. Your graph must have title. A graph of price of P in naira against Q in units. And it must have what? Date. Very important. And after plotting your graph, don't forget to write your scale. The scale you use. Don't forget to write your scale you use to plot that graph. 2 cm represents so unit. 2 cm, like this one is in naira now. 2 cm, you can say 2 cm depending on if you are using 2 cm. 2 cm means that big boss. That 2 cm means that big boss. That you are using that standard wire graph sheet. That 2 cm means what? That big boss. And that big boss means that you are saying 2 cm represents so naira for vertical axis, and also 2 cm represents so unit for horizontal axis. Ensure you put your scale, put your title, put your date after plotting your graph or while plotting your graph. Very important. Then as we come to this one now, the same thing, put your title, date, scale, use. We have discussed all those things in our channel, so we don't want to take your time discussing it again. You go to our channel, you see how we discuss this. Introduction to Physics Practical. Chidos Daniel, Introduction to Physics Practical. You watch a lot there. Okay, now here we call here our what? V2. This is your V2 and this is your V1. V2 is always up, V1 is down. Then where the vertical and horizontal meet, it will become your I2, and this one become your I1. Where the vertical and horizontal meet, trace it to horizontal, it become your I2. So change in V over change in I will be giving us, change in V is minus 1 minus bracket minus 5. This minus we wrote here is constant. This minus, that is what we mean. All over. Then this one, I2 is what? 4 minus 1. That will be giving you minus 1 minus minus. Minus times minus is plus. So minus 1 plus 5, 4. 4 over what? 4 over 3. It is positive. It is not negative. That means the slope of this graph is positive. Then when they ask you about intercepts on the vertical and on the horizontal axis, it means where does it touch your I axis and where does it touch your what? V axis. For your V axis on, we say that it touches your V axis on at intercept on the what? Vertical axis V is equal to minus 6 volts. Remember, it is negative at the negative side. If you write it as positive, you have failed it. Minus 6 volts. Remember, we are using V and I as a case study, so to speak. We are using it as an example, so to speak. Then I watt, intercept on the watt current part is equals to, let's say here is 4.1 watt ampere. You attach your unit. So whenever you are plotting all this, ensure you are putting your unit by the watt side. I'm not giving more emphasis on that because we have discussed it. I'm just talking about how to know your slope, whether it will be positive or negative. We have seen the first, the second, and the third. I will also see how to get the intercept. Intercept, meet here, you get it. Meet here, you get it. And attach your unit. Where it meets your horizontal axis, take it and write. Where it meets your vertical axis, take it and write. If it is positive, ensure it's positive. If it is negative, write it as negative. Very important. And so when you are done with this, you have done with your what? Intercept and your slope. And this is positive. Please, I believe you will not make the same mistake again. You will not make mistake on this again. Okay? Yes. We will try as much as possible to see that every difficulty you encounter in phases, in calculation courses, we will trash it down by God's help. Okay, come to this now. Want to plot this graph. Now, for this graph now, this can pass here or can pass here depending on the graph you are plotting. We want to talk about this first. To talk about this one, let's say we are plotting graph of price against quantity, for instance. Just do the same thing. Here becomes your what? Let's say minus 2, right? Let's say minus 2. And here becomes your what? Minus 5. That is your what? This is your P1 and this is your what? P2. P2 is minus 2 and P1 is minus 5. Okay? Then you ask where the vertical and horizontal meet, they meet here. So you take it up like this. This will be your Q2. And this will be your what? Q1. You use dotted line to do it. Don't use thick line. Don't use what? Thick line. Okay? So we say where the vertical and horizontal meet tells you to know the two parts when you talk about the horizontal part. So change in P all over change in what? Q. What is your P2 minus P1? This is P2 minus P1 all over Q2 minus Q1. Okay? So what is your P2? You say P2 is minus 2 minus, your P1 is minus 5. All over Q2 is 1 and Q1 is what? 4. What does it mean? Minus times minus plus. Minus 2 plus 5 is what? 3. All over 1 minus 4 is minus 3. That means the slope of this is 3 over minus 3 and equal to minus 1. Minus 1. That is negative slope. That is what it means. That any graph going that way is a negative what? Graph. What is the unit? Minus 1 naira per watt. Minus 1 naira per unit. Minus 1 naira per unit. The unit of P, which is naira, and the unit of Q, which is unit, you attach it by the side. Naira will be at the top, unit will be at the down. Minus 1 naira per unit. That is about your slope. We have talked about noting your what? Unit. Then your intercept. In this case, intercept on the vertical axis. Take this point. This point is about minus 1.5. Minus 1.5. Or you can say here is minus 1.5. Let's take here to be minus 1.5. That means the intercept for P part will be equals to minus 1.5 naira. Minus 1.5 naira. The unit must be attached to it. Then intercept on the horizontal part. It means you are to what? Extend this. Extend the horizontal distance so that this line of best fit can touch it or cut across it. So you note where it meets it. So when you extend it, you will now see that at this point, if here is 1 and here is 0, it's possible that here is minus 1. We say minus 1, 0, 1, 2, 3, 4. Are you getting it? So we say extend this horizontal axis. This is still your Q axis, negative Q axis in unit. And this is negative what? P axis in unit, in naira. So when you extend it, this line of best fit should touch it. And when it touch the Q axis, whatever you get at this point, if here is 0, depending on your scale, are you getting it? If here is 0, it means that here should be minus 1. Here should be negative. It must not necessarily be minus 1. Just read off where it meets your horizontal axis, depending on your scale. Wherever it meets your horizontal axis, take it out. That is just the instruction. So you now say IQ will be equal to negative 1 unit. Then IP will be equal to, where does it meet your P axis, your vertical axis? Is equal to minus 1.5 what? Naira. You attach the unit to it. Okay? So that is how to do it. Okay? So the first one gives positive slope, second one negative slope, third one positive slope, next one is negative slope. I believe you are clear with this. So if you are having a challenge, if you are still having a challenge on how to get to slope or intercept, please watch this very well. Let's interact on the comment box. So see if you truly understand this point. Okay, so let's go to how to find standard error in G. Let's discuss about the simple pendulum experiment. Okay, on our channel, we discuss simple pendulum experiment, and we showed on that channel, on Chidon's Daniel channel, Chidon's Daniel simple pendulum experiment channel. Okay, once you type Chidon's Daniel simple pendulum experiment channel, you'll see this video I'm talking about. So I showed on that channel how to get our table of value if you are asked to perform simple pendulum experiment without touching apparatus. Maybe time is running against you and you need to round off what you are doing as fast as possible. I showed how to get your table of values. These tables we are gotten from that video. Now some persons came to my DM to ask, please, how do we find our G? How do we find error in slope? How do we find standard error in G? In that video, I discussed how to get your slope, and I also discussed how to get your error in slope. Please, your slope and error in slope is different from G and standard error in G. I repeat, getting your slope and getting your error in slope is different from getting your G and getting your standard error in G. I say it again for the last time. Getting your slope and getting your standard error in slope is different from getting your G and getting your standard error in G. Okay? And so we saw in that video how to get your slope, and we also showed possible ways you can get your standard error in slope. I showed two methods in that video. Use of vertical scatter method and use of what? Line of difference between slope of best fit and slope of what? Worst fit. Their difference. Please type Chidon's Daniel simple pendulum experiment. You'll be able to see that video and watch it by yourself. Okay? Now, if you are given a table, if you have gotten your table of value, and you want to know how will my slope look like, what will be the range of my slope, we have discussed it in one video again, but we want to chip a point there. Now, you want to know the nature of your slope, how e go be like, and the statement or the instruction is plot the graph of L against what? Against t square. If I want to know my slope, I will just say when I plot the graph of L against t square, I will have L over t square. That means my slope will be changing L against changing t square. Okay? Now, what do we mean? I will say this means L2 minus L1 all over t square 2 minus t square 1. What do we mean by this? Remember we said that every line of best fit you have, its slope is always collinear. Yes, its slope is always collinear. Is that they are very same or similar? You will see it that way. And I discuss it that when you have something like this, the slope from here to here, it's something with slope from here to here, it's something with slope from here to here. That is what we mean by collinearity of what? Straight line. This principle only holds on straight line, so to speak. And so, I can decide to say, let me take this to be my L and this to be my what? T. So, I can say, let my L2 be what? 100. The highest point. Let the highest point be 100. And let the lowest point, I can take the lowest point to be what? 50. Then, because I took 100 here, I will take the t square. T square 2 will be equal to 4.08. And t square 1 will be equal to what? If here is 50, here should be 2.04. That means, going by this formula, possible slope on range of slope of it will be 100 minus 50 all over what? 4.08 minus 2.04. That will be 50 over what? 2.04. Now, 50 divided by 2.04, that will be giving us about 24.5. What is the unit? Centimeter per second squared. Because we say you must attach your unit to your slope you got. Now look at this one. Every of this table we have its unit noted. But when we plotted that graph, when we plotted the graph in that video, you know, when you plot your graph, the slope we got from that graph was approximately 25 cm per second square. That is because it is graph. Not just because it is graph. It is a sketch of the graph. You know, we use the board to do the graph plotting. We didn't use standard wire graph sheet to what? Plot it. If you use standard graph sheet to do your plotting, you'll be able to get your answer between 24 point something to what? 25. You now know you are seeing the range. But because we use a sketch of graph to plot it, we got 25. Now, I want to be using the 25 I got in that video, so that this video will be a continuation of what I got there. Somebody can use 24 points anything depending on what he got from this table. If you use standard standard graph sheet to plot this graph, you'll be able to get it about 24.5, 24.6, 24.7, 24.8, 24.9, 25, depending on the scale you use and how you succeeded to manage your scale very well in your graph plotting. Are you getting it? So you can use the way I plotted that graph and replicate it with your standard graph sheet you have. Replicate the process. Do your what? Connect your line of best fit so that you'll be able to get your slope, and you'll see that your slope will fall about 24 point something cm per second squared. So we are going by 25 because that is continuation of that video, right? Now we are getting our slope and we are asking ourselves, how do we get our G from this slope we have gotten? Remember that we noted that T is equals to 2 pi root L over G. Where did we get this question from? From simple pendulum experiment. This formula is constant. The formula said that period is equals to what? 2 pi root length all over G. So what do we do here? We make G subject of formula. To make G subject of formula, carry 2 pi, bring it inside the square root. To bring this 2 pi inside the square root, we say 2 times 2, 4. Pi times pi, pi squared, L over G. We now put square root. It means you have carried this 2 pi inside the square root. So to carry 2 pi and bring it inside square root, it means multiply that 2 into itself, you have 4. Multiply pi into itself, you have pi squared. We say is equals to t. Now, in mathematics, when you remove square root, you square the other side. We have t squared equals to 4 pi square L over G. We will no longer put square roots again because we have squared the other side. Now, making G subject of formula, cross multiply, G will come up, T square will come down. G will be equals to 4 pi square L over T square. What is your L over T square? L over T square is your slope. I repeat, L over T square means you plotted the graph of L against T square as noted. Are you getting it? So L over T square will automatically be your slope. And that means you say 4 pi squared times, if what you got in your slope is 24.5, say times 24.5. If it is 24.6, you would say times 24.6. If it is 24.7, say times 24.7. If it is 24.9, you say times 24.9. If it is 25, you say times what? 25. Are you getting it? So because we are using 25, because that is what is a continuation of that video, of the sketch of graph we had in that video, we got 25 to be our slope. We now say 12 pi square times 25. 4 pi square times 25. That will give us 987 approximately, equals to 987 cm per what? Second squared. Okay, still remember that we have gotten our G to be 987 cm per second squared. That was the G we got in that video. That video we said the slope is 25 and so G. So it's not a more that your own will be 987. No, if you are using by 24.5 that we got here some minutes ago, what you do is 4 shift pi squared times 24.5. You'll be able to get 967. So if you are saying G equals to 4 pi squared times 24.5, because that is what you got, for instance, it means that you'll be having what? 967 what? cm per second square to be your G. It's still in the range of value of G. Remember what brought up this whole video from the beginning was quest to what? Know how to run your experiment without touching your apparatus. Are you getting what we are saying? So that was why we started showing you how to get your readings accurately without touching your apparatus. In that video, remember I said I showed you guys how to get your error in slope. After we got our slope, I showed you there is a video I wrote it, Chidons Daniel, ways of finding error in slope and intercept. That was the topic. Chidons Daniel, ways of finding errors in slope and intercept. And I showed two possible ways you can do that. So I will not repeat that again. Just type Chidons Daniel, ways of finding errors in slope and intercept. You watch that video and enjoy it. Okay, now come to this one. We have gotten our G and want to get error, standard error in finding this G. That is the main thing. I think this question, so many persons ask me this question. So many persons ask me this question on my DM. Yes. Okay, let's see how we do it. If you want to get this, remember that you say G is equals to 4 pi square L over what? T square. Remember this. We just talk about this before now and clean it off. To find your error in G, standard error in G, this constant must disappear. 4 pi square is an ordinary number, and so we call it a constant, so it must disappear. So we will be having, therefore, G will be equals to what? L over T square. Now, remember that the highest value you have here is 100. The maximum value of length you have is 100. You say length is equals to 100 plus or minus 0.1 centimeter. This plus or minus 0.1 centimeter is called the standard error. Standard error of finding what? Length. Are you getting it? 100 plus or minus. So if I'm picking this 100 because that is the maximum now, I will pick the maximum period. That is T equals to what? 2.02 plus or minus 0.01 seconds. You say this is standard error and this is standard what? Error. That means the standard error in finding period time is equal to 0.01 second. Sometimes you see it as 0.1. Sometimes you see it as 0.01 second. So it can be 0.1 or 0.01 depending on whether it's stopwatch or stop clock that is used. Okay? But in this experiment, its own is what? 0.01. You can see it 0.01. 0.01, like it goes into decimal, so to speak. Okay, now after I have taken the maximum length and the maximum period, I can now start up. I will now say standard error in finding G all over G is equals to square root of, this means LT raised power minus 2. That is what it means. Square root of, we now say, what is the power of this length? 1. 1 times standard error in finding length, all over length, all squared, plus, what is the power of this T? Minus 2 times standard error of finding period, all over what? Period, all squared. This is what we have to do. That means our SG, making SG subject of formula, that is standard error in finding G, is equal to this G will be multiplying G times what? Square root of what? 1 times SL all over L all what? Squared plus what? Minus 2 times what? ST all over T all what? Squared. That gives you SG equals to, your G is 987 times square root of, we'll be having 1 times standard error in length 0.1. That 0.1 we are writing as standard error in length. It's the same thing with what? Maximum error in length. And it's also the same thing with the reading accuracy of the what, the ruler or what you use to measure your length. Take for instance, if you say that this is your ruler and here is 0, here is 1, here is 2. You have a tiny line about 10 of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have a tiny line of about 10 of it. 1 minus 0, 1 all over. How many tiny lines do we have? 10. That will be giving you 0.1 cm. So we use 100 cm meter rule in doing that experiment. And that is why we are saying reading accuracy of it is 0.1, which is equivalent to maximum error, which is equivalent to the least distance we can get here, and which is equivalent to standard error, so to speak. All over what? 100 all what squared plus what? Minus 2, that is the power we just talked about, times what? Times 0.01 all over what? All over 2.02 all what squared. That is all we are saying. It will be giving you 9.82 centimeter per second square. That is your what? Standard error in finding your G. Now, as you have gotten standard error in finding your G, you must package your G now this way. Say, my G is equal to 987 plus or minus 9.82 cm over second square, SE. SE means standard error. Or change this to be in what? Meter. You have G equals to 9.87. How do we get it? To change centimeter per second square to meter per second square, divide this by 100. You have 9.87 plus this divided by 100, 0.0982. We divide this by 100, you have this meter per second square, SE. That is also accepted. So that is how you can what? Get your G and the standard error in what? G. If you find this video helpful, please don't forget to click subscribe, click like button, turn your notification button on, comment, share to your friends. I'm happy. I appreciate for all the good things you guys have been doing for me, promoting and supporting my channel. Yes, I appreciate it a lot. God bless you all. Please don't give up in helping me and in supporting me. Continue spreading the good news. I will be doing all my possible best to be creating contents that will help us in our courses. Practical physics, chemistry, maths, we will say those contents so that we'll continue doing well in our various courses. Okay, so that is how to get your standard error in G. Don't forget to click Chidon's Daniel, then type what? Simple pendulum experiment. You see the video where it started from. Then click Chidon's Daniel, then ways of finding what? Error in slope. You also see video for that one. Then also don't forget that we have another channel which is the Chidon's Academy class. The Chidon's Academy class. For this one, this is our second channel. Please do well to go to this channel. Do well, if you find this video helpful, do well to go to this channel and click subscribe for me. Follow me up in this second channel if you have not done that. Ensure that these two channels you are following me up there, please. I'll be posting on these two different channels. I'll be posting different contents there, still on science courses, okay, so that you will not miss out. And this is my contact in case you want to chat me up for any question, or for you to get cleared in one or two things, or if you want to even support me financially or gift me, or you can also chat me up. So it's not all the time you disturb me. The one you have been doing, the support, the gift, I appreciate. So don't give up. Don't give up in doing what is right or fine. That is how we call it a day in today's practical phases. We will go to more content, more experiments. See you in our next practical.